Good afternoon, students. In the last class, we have completed process on vapor. There is two processes, that is constant volume and a constant pressure process. In a constant volume process, the volume before and after the process remains same. That means V1 is equal to V2. That I will show here. Right, this is a constant volume process. Here the volume before and after the process is remains same, that is V1 is equal to V2. For derivation purpose, I already told you, we have taken a wet steam, 1 kg of wet steam before and after the process. Therefore, say at the last line V1 becomes x1 Vg1 and V2 becomes x2 Vg2, because both are wet condition. So, according to the process, we have initial volume is equal to final volume, that is V1 is equal to V2. So, x1 Vg1 is equal to x2 Vg2. Therefore, the final dryness fraction x2 becomes x1 Vg1 divided by Vg2 is the final dryness fraction of the steam after the process. So, if depends upon the value of x2, you have to decide the final condition of steam in order to work out the problems. If x2 is exactly 1, then the final condition of steam is dry, that you know. If it is more than 1, then the final condition of steam is superheated. So, the relation changes. See there, first note x1 Vg1, initially we are always taking a wet steam, is equal to finally it becomes dry, because x2 is exactly 1. Therefore, just Vg2. If x2 is more than 1, then you should take like this, x1 Vg1 is equal to Vg2 into T sub plus 273 divided by T sat plus 273. Depends upon value of x2. While solving the problems, you should change the relation, that is x1 Vg1 is equal to x2 Vg2 is going to change. Okay. After that, we gone to work done. We know that work done is pressure into change in volume. So, here the volume remains same, therefore, V1 is equal to V2, there is no change in volume, therefore, the work done P into 0, because you know V1 is equal to V2, therefore, work done is 0. Next, we gone to change in energy. We know change in energy always E is equal to enthalpy minus work done, H minus W is a general relation. So, if you take for wet steam, initially assuming initially and finally the condition of wet, we have E wet 1, that is equal to H wet 1 minus W wet 1, for that you know the relations. Similarly, E wet 2 is H wet 2 minus W wet 2, therefore, change in energy delta E is nothing but E wet 2 minus E wet 1. So, here also I have given the note, delta E is I told E wet 2 minus E wet 1, but if the final condition is dry, that is become E d2 minus E wet 1. Suppose the final condition becomes superheated, that becomes E sub 2 minus E wet 1. And lastly, we gone to heat transfer. According to first law of thermodynamics, heat transfer Q is nothing but change in energy plus work done, that is delta E plus W. So, W is 0, you know why, because volume is constant. When volume is constant or remains the same, there is no work done. Therefore, Q is delta E. Delta E is nothing but E wet 2 minus E wet 1. Very important here is, in a constant volume process, always the amount of heat transfer is equal to change in internal energy, that is Q is equal to delta E. Suppose in the problem, if they ask find heat transfer, you just find delta E. Delta E is nothing but E wet 2 minus E wet 1. This is a constant volume process. So, now we will directly go to the problems on a constant volume process. So, right. So, problems on constant volume and pressure process. Pressure process we will take later. So, first we will go to constant volume process. The first problem, steam at a pressure of 4 bar and dryness fraction 0.7 is allowed to expand at a constant volume until the pressure rises to 5.6 bar. Calculate the final condition of steam and the heat absorbed by 1 kg of steam. So, first you should decide in which process the problem is as given. So, here very clearly given that at a constant volume. So, initially pressure is 4 bar, dryness fraction of 0.7, that means the initial condition of steam is wet. Why? Because dryness fraction is given, that is clear. Next, at constant volume the pressure rises up to 5.6 bar. This is the final condition of steam, final pressure of steam, not condition. Pressure of steam is 5.6 bar, but we do not know the condition of steam. That means initially it is wet, after the process whether it is dry or superheated we do not know. So, first you have to find the final condition of steam by finding the value of x2. The amount of steam given is 1 kg. Okay. Now, I have taken values from the steam table for 4 bar and 5.6 bar. See there Vg, Hf and Hfg I have taken for initial and final pressure of steam. Next, first our intention is to find the final condition of steam. So, for that in a constant volume process we know that x2 is equal to x1 Vg1 divided by Vg2. Why I have taken x2 Vg2? Assuming that final condition of steam is always wet. After finding x2 only you can take exact condition of the steam. So, there by substituting all the values we got x2 is equal to 0.961. So, observe the value, it is less than 1, therefore, the final condition of steam is wet. Now, for a constant volume process what is heat absorbed? Q is equal to delta E. Why Q is equal to delta E? Because the work done becomes 0. Therefore, Q is equal to delta E, that is E2 minus E1. Now, you can take in place of E2 E wet 2 and minus in place of E1 E wet 1. Why? Because initial condition is wet, it is given in the problem, no doubt, and E2 in place of E2 I have taken E wet 2. Why? Because the final condition is also wet, we got x2 value is 0.961. Therefore, both the relations I have taken wet. This is very important. Finding x2 is first important, next depends upon the value, taking the internal energy formula for 2, that is E2 is again important. Okay. Here both the conditions are wet. Now, first you find E wet 1, substituting all the values you are getting 1968.72. Next E wet 2, again substitute all the values for the second pressure, that is 5.6 bar. So, you will get 2496.64 kilojoules. So, E wet 1 and E wet 2 you got. Next, therefore, change in internal energy delta E is equal to E wet 2 E wet 1 minus E wet 1. So, you will get 521.92. Therefore, in a constant volume process heat absorbed is nothing but change in internal energy. So, Q is equal to delta E, the same answer for heat transfer also. So, like that first find x2, decide final condition of steam and take the formula for condition depends upon the condition of steam and get your Q. Q is always in a constant volume process is equal to delta E. So, first problem is over. Next, second problem, it is important problem. Second problem, a vessel contains 2 kg of steam at 6 bar and 0.9 dry. Calculate quantity of heat which must be rejected so as the quality of steam becomes 0.7 dry. First you understand the problem. So, here a vessel contains 2 kg of steam. In a vessel 2 kg of steam is there. So, that means it is constant volume only or it is in a closed condition. So, it is a constant volume process. 2 kg of steam is there at 6 bar and 0.9 dry. That means initial condition of the steam is wet steam because dryness fraction is given. 0.1 is clear. Next, calculate the quantity of heat, that is you should find Q. Q is nothing but delta E which must be rejected so as the quality of steam becomes 0.7 dry. So, you observe that word which must be rejected. Why? Because see initially the quality of steam is 90% dry or x is equal to 0.9 dry. After the process the quality becomes 0.7 dry. See the quality reduced, that means the amount of water particle is more the amount of steam is less. That means the quality of steam has reduced. Therefore, he asked what must be rejected heat. Okay. So, initially it is wet, finally is also wet. So, here no need of finding your x2 because he has given in the problem x1 is 0.9 and x2 is 0.7 initially and after both the conditions are wet, right. So, now you take the value from the steam table. Observe this problem, only one pressure is there. So, only 6 bar is given. After the process the pressure is not given, he has given the quality of steam. This is very important. So, only one pressure is there. For that I have taken the value Vg I have taken, Hf I have taken and Hfg also I have taken. Now, how to find the final pressure? So, why we need final pressure? So, we need the value of Vg2, Hf2 and Hfg. So, to take all that I required a pressure. So, therefore, first you should find the final pressure. So, how to find that? So, what is the relation in constant volume process? X2 Vg2 x1 Vg1 is equal to x2 Vg2, that is V1 is equal to V2. The common relation is there. I have put a star there, the star is just for important. Okay. Here we know the value of x1 Vg1 from the table and x2 is given in the problem, that is 0.7 given in the problem. We got Vg2 is 0.406 meter cube per kg. Here very important, say 0.406 meter cube per kg is the value of Vg2. So, now you please go to your steam table. In the steam table you observe the value of 0.406 in Vg column, that is specific the volume of steam Vg. In that column you observe for 0.406. So, where you are getting 0.406 in that column you should take pressure P2, that is 4.6 bar and enthalpy Hf is 626.8 and latent heat Hfg is 2118.2. Normally pressure is given. So, depends upon the pressure we are taking all three values, but here the final pressure is not given. Therefore, we have to find Vg2 or Vg value. Depends upon Vg value we have taken the pressure, ulta case or reverse case. So, P2 is 4.6 and corresponding values you got Hf and Hfg. Now, for a constant volume process you continue similar to previous problem, that is what is heat transfer according to first law. Q is equal to delta E plus W, but constant volume process W becomes 0, therefore, Q is equal to delta E. So, we know that both the conditions are wet, therefore, I have taken directly Q is equal to delta E is equal to E wet 2 minus E wet 1. You apply formula for E wet 1 and E wet 2, substitute all the values, you will get E wet 1 and E wet 2 around 2377.63 is E wet 1 and E wet 2 value is 1978.8 kilojoules per kg. You observe internal energy also here. See, E wet 1 is 2300 something and E wet 2 is 1978 because the quality has reduced, the dryness fraction becomes 0.7. Therefore, the amount of internal energy is also less after the process. Therefore, what is Q now? So, therefore, change in internal energy G delta E is equal to E wet 2 minus E wet 1 final minus initial, that we got minus 398.83 kilojoules per kg Kelvin. So, why here a minus? So, so much, that is 398.83 kilojoules per kg of heat as rejected from the steam. So, therefore, we want for 2 kgs because in the problem he has given for 2 kgs. Therefore, the heat transfer for 2 kgs is 2 into your delta E, that is 2 into minus 398.83 minus 799.66 kilojoules kilojoules of heat is rejected from the steam. There is no kg, only 799.66 kilojoules of heat as rejected from the system. So, this is the second problem. In the second problem, important is final pressure is not given, but final condition is given. Depends upon the final condition, you should find Vg depends upon Vg, you take P2 and other values. So, third problem, steam of 1 kg at 1.4 bar and 0.62 dry. So, first initial condition is clear, 1 kg steam, 1.4 bar and 0.62 dry is heated at constant volume. He has given the process also constant volume until the pressure becomes 3.5 bar. Calculate the heat supplied during the process. So, initial condition is wet, the constant volume process, final pressure is given, but final condition is not known. First you should find the final condition of steam by finding value of x2 similar to first problem. So, first you take the values from the steam table for 1.4 bar and 3.5 bar, all the values I have taken. Next we will go to x2 value, that is final condition of the steam. So, in a constant volume process you know that V1 is equal to V2 or x1 Vg1 is equal to x2 Vg2. So, by substituting all the values I got x2 is 1.46. Say observe the value of x2 here, this is the third problem. So, x2 is more than 1, then the final condition of steam is superheated. There is a star there, that means important. So, x2 is more than 1, so final condition is superheated. Therefore, the initial relation has changed, observe there. Therefore, x1 Vg1, that is correct because initial condition is wet, is equal to, I have taken V sup 2, no x2 Vg2 there. Why I have taken V sup 2? Because the final condition is superheated, that is because x2 is more than 1, 1.46. Therefore, x1 Vg1 is equal to V sup 2. What is V sup 2? Vg2 T sup plus 273 divided by T sat plus 273. So, here in the problem T sup is not given. So, you have to find when the final condition of steam becomes superheated, you should find the degree of superheat. I already told in the previous classes, definitely you have to find the value of T sup 2. From this relation you find T sup 2, substituting x1 Vg1 on remaining values. So, you will get T sup 2 is 602.18 minus 273, that is 329.18 degrees C is the superheated temperature. If you want degree of superheat, the T sup minus T sat is around 138.9. So, 329.18 minus 138.9 will give the degree of superheat. Okay. So, now the final condition is superheated, we have the superheated temperature is 329.18. Next, according to the first law, for a constant volume process, heat transfer Q is equal to delta E, because the reason you know W is 0. Okay. So, what is delta E here? So, delta E is equal to E2 minus E1, that means generally we have taken E wet 2 minus E wet 1, but in this case you should not take like that. So, E wet 1 is wet only, no doubt in that. That formula you apply, HF1 plus x1 HFG1 minus 10 square P1 x1 Vg1, substitute all the values, you will get the internal energy of initial condition of steam, that is E wet 1 is 1734.86 kilojoules per kg. So, this is a initial internal energy. So, observe here the final internal energy of the steam, I have taken superheated. E sup 2 is equal to HF2 plus HFG plus Cp T sup 2 minus T sat 2. This is the enthalpy of superheated minus work done of superheated is 10 square P2 V sup 2. So, substitute all the values. Why you have taken E sup 2 there? Because the final condition is superheated. So, substituting all the values, I got around 2863.88 kilojoules per kg of internal energy of final condition of the steam. Therefore, change in internal energy is E sup 2 minus E wet 1, final is superheated, initially is a wet steam. Therefore, we have this relation. So, delta E is around 1129.02 kilojoules per kg. He asked for only 1 kg. Therefore, Q is the same answer, that is 1129.20 kilojoules per kg. So, in the first problem we have taken both the conditions are wet, initially and after it is wet. In the second condition also initially and after is wet, but in the second problem the pressure is not given, you have to find the pressure. In the third problem initially it is wet and finally it is superheated. So, it depends upon the condition of steam, you have to change your formulas, right. So, next we will go to the constant pressure process. So, I have completed 3 problems in constant volume process. Similarly, you will get in the examination also. So, now we will go to constant pressure process. Before going to constant pressure process, we will review the process once again. In the last class we have completed. So, once again I will review that process. We will go to constant pressure process. What is constant pressure process actually? In a constant pressure process, the pressure before and after the process remains the same, that is P1 is equal to P2. Just I have taken P. When P1 and P2 becomes a constant, automatically Vg1 is also is equal to Vg2, that I have taken Vg, because for pressure P, if you take a value of Vg1 and Vg2 for a constant pressure, both the values are same, therefore I have taken Vg. So, initial volume, by assuming initial and final condition of steam is wet, for derivation purpose V1 is equal to V2, say. So, V1 is x1 Vg1, just I have taken Vg, because Vg1 is equal to Vg2 is equal to Vg. Similarly, V2 have taken x2 Vg. So, now depends upon the condition, that will changes, that I have given there, and also we have discussed it in constant volume process. Next we will go to the work done. So, work done is pressure into change in volume. So, pressure is 10 square P, change in volume is nothing but V2 minus V1. V2 is x2 Vg and V1 is x1 Vg1, in that common is Vg. So, therefore, I have taken out the work done formula for constant pressure process is 10 square P Vg x2 minus x1. So, there is a note there, if the final condition is dry, x2 becomes exactly 1. So, observe the relation 1 minus x1. Suppose the final condition is superheated, we in place of x2 Vg2 we are taking a V sup 2, because the steam is superheated. So, that 2 changes depends upon the condition. Next we gone to change in internal energy. You know that E is equal to H minus W, that is E wet 1 H wet minus W 1, assuming initial condition is wet and assuming final condition is also wet. So, E wet 2. So, delta is equal to E wet 2 minus E wet 1 is the change in internal energy for constant pressure process, similar to your constant volume process. Here also there is a change, depends upon final condition of steam. If final condition of steam becomes dry, that becomes delta E is equal to E dry 2 minus E wet 1. Final is superheated, that becomes E sup 2 minus E wet 1. By simplifying or by substituting E wet 1 and E wet value there, we got delta E is equal to H wet 2 minus 10 square P2 x2 Vg2 minus H wet 1 plus 10 square P1 x1 Vg1 is the delta E, that is E wet 2 minus E wet 1. Next according to first law, we have heat transfer Q is equal to delta E plus W. What is delta E? Is E wet 2 minus E wet 1 plus W. So, substitute the E wet 1 and E wet 2 in a corresponding places, and you will get just Q is equal to H wet 2 minus H wet 1. This entire derivation, how we will get H wet 2 and H wet 1, I have explained in the last classes. Now, just I will go to Q. So, Q is equal to H wet 2 minus H wet 1, that is nothing but what? Delta H, that is change in enthalpy. So, here it is very important, the conclusion in a constant pressure process says the heat transfer is equal to change in enthalpy, that is the important. So, in a constant volume process Q is equal to delta E, but in a constant pressure process Q is equal to delta H. Suppose they ask find heat transfer in a constant pressure process, you just find delta H, that is enthalpy of initial steam, enthalpy of final steam, take the difference of that two, you will get heat transfer Q. Okay, we will go to the problems on constant pressure process. Okay, we will start from here. See, first problem on constant pressure process. 1 kg of steam at a pressure of 17.5 bar and dryness fraction of 0.95 is heated at a constant pressure until it is completely dry. See, initial condition of the steam 17.5 bar and dryness fraction of 0.95. So, initial condition of steam is wet steam, is heated at a constant pressure, that means final pressure is also 17.5 bar only until is completely dry. See, final condition is also given, initially it is wet and finally it is dry. Determine increase in volume. Number 2, the quantity of heat supplied and change in entropy. So, 3 details he want, increase in volume, heat transfer, then entropy. So, you take the value from the steam table just for one pressure, because initial and after the pressure is same. So, I have taken all the value Vg, Hf, Hfg and entropy he asked, therefore, I have taken Sf and Sfg. Okay. First, increase in volume. What is the initial condition is wet, therefore, I have taken V1 is equal to x1 Vg, that is you are getting around 0.10735. Finally, the condition of steam is given in the problem, that is dry, therefore, I have taken V2 is equal to Vg directly, no x2 there, because x2 is equal to 1, right. V2 also you got. So, increase in volume is always final minus initial, that is V2 minus V1, you will get around 0.00565 meter cube per kg, that is the increase in volume. Next, heat supplied Q. We know that in a constant pressure process, the heat transfer Q is equal to delta H, that is change in enthalpy. So, general relation I have taken there H wet 2 minus H wet 1, but for this problem you have to take H dry minus H wet 1, because the final condition is dry steam, right. So, there initial enthalpy of wet steam, initially it is wet, you know the formula Hf1 plus x1 Hfg1, you got around 2700.5. Next, enthalpy of dry steam, that is H dry is equal to Hf2 plus Hfg2, there is no x there, because final condition is dry, you will get around 2796.4 kilojoules. Therefore, heat supplied is equal to Q is equal to delta H, that is H dry minus H wet 1. So, you will get around 95.9 kilojoules per kg of heat supplied. Next, change in entropy he want, initially it is wet and finally it is dry. Therefore, we know entropy of wet steam, that is Sf plus XHfg. So, you will get 6.1897 kilojoules per kg. Similarly, dry steam, entropy of dry steam, there is no x, Sf plus Sfg. So, you will get around 6.39 kilojoules per kg. Therefore, the change in entropy delta S is equal to the final condition of steam minus initial condition of steam. The final it is dry, that is Sd, minus initial it is wet, Sw, you will get 0.2003 kilojoules per kg Kelvin of entropy, that is change in entropy for this process. So, like that for constant pressure process, there is a actually in a constant pressure process there is a work done, there is internal energy and heat transfer. So, this is the first problem in constant pressure process. Then we will go to the second problem. 1 kg of steam at a pressure of 17 bar and 300 degree C is cooled at a constant pressure until its quality becomes 0.85. Find the heat supplied and work done, taking Cp is 2.1 kilojoules per kg Kelvin. So, first you identify the initial condition of steam, pressure of 17 bar and 300 degree C. Once the temperature is given, automatically it is a superheated steam. The value of 300 degree C is T sup. Is cooled at constant pressure. So, final pressure is also 17 bar. Next, until its quality becomes 0.85. So, second condition is also given, or final condition is also given, that is wet steam, because dryness fraction is given. Okay. Initially it is superheated steam, finally it is a wet steam. depends upon the quality, you should alter your relations. Okay, you should find heat supplied and work done. So, take the values from the steam table at what bar? 17 bar. Say I have taken saturation temperature value, Vg value, Hf and Hfg values. So, first we will find heat supplied. Okay. So, in a constant pressure process, what is heat supplied? Q is equal to delta H. That is, general relation is H wet 2 minus H wet 1 actually, but here I have taken H wet 2 minus H soup 1 because final condition is wet, that is clear. Initial condition is superheated because temperature is given. Okay. Now, one by one you go on finding. First you find H soup 1, you know the formula. So, you will get around 296.67 kilojoules per kg of enthalpy. Next H wet 2 final steam condition is wet, that formula Hf plus XHFG, you know the value, final dryness function is given 0.85, you will get around 2507.16. Therefore, Q is equal to H wet 2 minus H soup 1, you will get around minus 489.51. Why here it is minus? Because initial condition is superheated, then it becomes wet steam. So, quality of superheated steam is better than quality of wet steam. So, minus because heat is rejected from the steam. Therefore, we got a minus. Next work done you want. What is the work done formula for a constant pressure process? W is equal to 10 square P V2 minus V1. So, first you should find V1, next V2, substitute, you will get work done. So, what is V1? Initially it is superheated, V1 is nothing but V soup, therefore, V soup is nothing but Vg T soup plus 273 divided by T sat plus 273. So, substituting the values, V1 is nothing but 0.1404 meter cube per kg. The final condition is wet, therefore, I have taken V2 is equal to XVg. X is given in the problem 0.85 and 0.117 from the steam table at the same bar, because it is a constant pressure process, we will get V2 is 0.09945 meter cube per kg. Therefore, work done is equal to 10 square into P into V2 minus V1. We have both the values. So, we will get work done is also minus. Again same reason, initially it is superheated, after the process it becomes wet steam, therefore, the heat has rejected, therefore, the work done is also negative around 99.3036 0.18 so 303 kilojoules per kg of work done is done by the system. So, like that depends upon the condition of steam, you should work out the problems. Okay, the two processes we have completed, constant volume and constant pressure process, and third process in vapor is constant temperature process or isothermal process. In this process, the wet steam has only one temperature, that is saturation temperature corresponding to a given pressure. Thus, the heating of wet steam at a constant temperature till it becomes dry saturated is similar to that of heating at a constant pressure. So, that means if we go to steam formation diagram, in the steam formation diagram, after boiling point, that is temperature at boiling point is saturation temperature, after boiling point by further heating the steam begins to start up to where? Up to dry condition. Between boiling and dry, the temperature and pressure both are same. Therefore, see there, wet steam has only one temperature, that is saturation temperature corresponding to a given pressure. That means, in that region temperature and pressure is same. Thus, heating of wet steam at a constant temperature till it becomes dry steam is similar to that of heating at a constant pressure. Therefore, the same expression, see this line is important. If isothermal process or constant temperature process is asked in the problem, so therefore, the same expression for the work done, change in energy and heat is observed may be used for constant temperature process or isothermal process. That means, whatever the relations we have used in a constant pressure process, that is work done, change in energy and heat absorbed formulas in constant pressure process you can use for isothermal process also or constant temperature process. Okay. Once the steam is dry and superheated, it behaves like a perfect gas, or superheated steam follows the law of PV is equal to constant, that is P1 V1 is equal to P2 V2. The law may be regarded as a hyperbolic law, that is it follows Boyle's law, that means the temperature is constant, that means up to dry steam. So, you can use the formulas what you have used in a constant pressure process for constant temperature also. Once it has reached dry, by further heating it becomes superheated steam. In that area the temperature starts increasing. Therefore, when the steam becomes superheated you cannot use that formulas. So, because it behaves like a perfect gas, therefore, it follows the law of hyperbolic. So, what is hyperbolic law? Actually it is PV is equal to constant. Therefore, there is no derivation for isothermal or constant temperature process. Directly we will